chemical reactions of hydrocarbons. Chemical reactions of hydrocarbon. सबसे पहले let us learn about combustion. Whenever we talk about combustion, combustion means the reaction with oxygen. So since these hydrocarbons, they have got only hydrogen and carbon, so hydrogen will react with oxygen and it will give H2O, and carbon will react with oxygen and it will give CO2. So combustion, we can write that hydrocarbons burn in oxygen to give CO2 and H2O. Alright, and a lot of heat is generated also, along with heat and light, or along with heat and light. So we can take any hydrocarbon, say supposing if I take CH4, burn it with oxygen, then what I will be getting? CO2 plus H2O, and I can write over here 3O2. Another hydrocarbon, if I take C2H5OH and burn it in oxygen, what I will be getting? Accordingly, I will be getting CO2 plus H2O. So to balance this, you will have to make it an even number. So this will become CO2 and H2O. This will become 4 carbon. It will become 4 carbon over here. 4 carbon over here, and this is 5 2s are 10 plus 2 12. So this is 6 H2O, and you see now oxygen, how many we have? We have got 6 plus 8. 6 plus 8, that is 14 carbon we have, 14 oxygen we have. So we can write 7 O2 over here. Alright, so that is in nutshell what we understand is that any hydrocarbon, when it burns in oxygen, completely burns in excess of oxygen, then this will give out CO2 and H2O. Fine. Alright, now this is when it is burning in the presence of excess of hydrogen, excess of oxygen. Now if it is, another property is catalytic oxidation. Catalytic oxidation. Alright, catalytic oxidation. Now catalytic oxidation, when we do catalytic oxidation, then what will happen? Catalysts are substances which do not undergo change themselves but increase the rate of reaction. That is known as catalyst. Now for this catalytic oxidation, this is oxidation. So for this catalytic oxidation, what catalyst we are going to use is, we are going to use acidified K2Cr2O7, or we will be using alkaline KMNO4. Two catalysts we will be using. We can use either acidified K2Cr2O7. This is known as potassium dichromate. potassium dichromate, and this is known as potassium permanganate. Potassium permanganate. Potassium permanganate. Alright, so with any of these two catalysts, what will happen? Now just see supposing if I begin from ethane and I am doing in the presence of alkaline KMnO4 or in the presence of acidified K2Cr2, this is or, not both things will not be there. In the presence of either alkaline KMnO4 or acidified K2Cr2O7, what will happen? Oxidation will take place, and now one oxygen will add over here. That means what do we get? What do we get? Now this was earlier, this was ethane. From ethane now we are getting ethanol. We are getting ethanol. Now this is further, if we are going to continue this oxidation, then what we will be getting? We will now, oxidation, when we talk about oxidation is either addition of oxygen or removal of hydrogen. So another, if we are continuing this, then what we will be getting? This will become C, H and O. That means now the group is aldehyde. This will become ethanol. 2H has been removed. So over here this becomes now ethanol. Alright, ethanol. Further, we are continuing this oxidation. When you continue this catalytic oxidation, then finally what you will be getting is CH3, C, CO and OH. Alright, so this is acid. This is known as ethanoic acid. So remember, this is a very important reaction. Catalytic oxidation. First we are taking alkane, and this alkane, when we are doing catalytic oxidation to it, this will change into ethanol. Then this will change into an alcohol. Whatever alkane we have taken, this will change into all, and from all OH group, now it will change into al, that is aldehyde. Alright, then from aldehyde it will again, another oxygen is added over here. As you can see, another oxygen is added over here, and this will become COOH. That is, it's from, in this case it becomes ethanoic acid. So this is known as catalytic oxidation. Alright, now then we have learned about combustion, we have learned about catalytic oxidation. Now the third reaction what we are going to learn is that of addition reaction. Addition reaction. Addition, that is, something is adding. Now I have told you in my earlier lessons also, that is, these alkanes undergo substitution reaction, whereas alkenes and alkynes, they will undergo addition reaction. Alkenes and alkynes, they undergo addition reaction. So addition reactions, let us see addition reaction. We understand that is, this will be in the presence of alkene, this will be shown by alkenes and alkynes. So say supposing if I take an example like this, this is ethene. Now what I have to add to it, this double bond will, which is showing unsaturation, this double bond will change into single bond, and this is H will attach to each carbon. So this process will take place in the presence of nickel or palladium or platinum as catalyst. Alright, so nickel can be there, palladium can be there, or platinum can be there, and when these are there, then this hydrogen will attach like this and this will now become ethane. Now over here also, this is also, ये भी बहुत important reaction होता है. ये कहाँ काम आता है? ये काम आता है hydrogenation of oils. Hydrogenation of oils. जो भी हम ऑयल देखते हैं, जिसको हम रिफाइंड ऑयल कहते हैं, इस ऑयल में जब हाइड्रोजन पास करी जाती है इन द प्रेजेंस ऑफ दीज कैटलिस्ट निकल, प्लैटिनम और पैलेडियम, तो ये सॉलिडिफाई कर जाता है. इट कम्स इनटू सेमी सॉलिड, जो घी बन जाता है, जिसको वनस्पति घी कहते हैं. सो दैट इज लिक्विड ऑयल, और इसका हम हाइड्रोजिनेशन करते हैं in the presence of nickel और palladium as catalyst, और ये बन जाता है वनस्पति घी. वनस्पति घी, एंड दिस प्रोसेस इज नोन एज हाइड्रोजिनेशन. जो लिक्विड ऑयल है इसमें डबल बॉन्ड्स हैं, अनसैचुरेशन है, और जिस वक्त हमने इसको हाइड्रोजिनेशन किया, इसमें हाइड्रोजन ऐड हो गया, then this becomes a वनस्पति घी. Alright, now we have learned about 3 reactions. Addition reaction we have learned. Alright, now the last one, that is substitution reaction. Substitution reaction. अब ये substitution reaction, I have told you that this substitution reaction, इसमें एक bond टूटेगा तो उसकी जगह पर दूसरा कोई लेगा. So this is shown by saturated compounds such as alkanes. Alright, such as alkanes. So say supposing if we have an alkane over here, and this alkane, instead of this H is removed from here and H is replaced by a halogen, then this becomes substitution, because the structure remains the same, only that place of hydrogen is taken up by halogen. So this is known as substitution reaction. Alright, so this reaction, say supposing if I take the example of ethane, if I take the example of ethane, and if this is done halogen, then over here this has to be in the presence of light. Alright, in the presence of light this reaction takes place, and now we will be getting number of products. How we will be getting? Say we will be getting 1 Cl over here, so this becomes monochloro. Alright, this becomes monochloroethane. Alright, then I may be having, so this becomes 1,2-dichloroethane. Alright, then I can be getting CC. So chlorine and chlorine. This is trichloro I have written, and this is on the same carbon if I have written. So this will be 1,1,1 trichloroethane. Alright, then this is all these products I will be getting. So similarly I will be getting tetrachloro, so this is 1 and 2 tetrachloroethane, and then after that again similarly so this is 5 pentachloroethane, and finally I will be getting hexachloroethane. So I will be getting a mixture of all these products. The necessary condition for this is that light should be present and ethane will react with halogens, and this reaction is known as substitution reaction. Substitution reaction, the structure does not change, only one H is removed and the place is taken up by a halogen. Yes, thank you. Alright, welcome students. So, carbon and its compounds. So, continuing in this chapter, carbon and its compounds, we are using a lot of these carbon and its compounds as our fuels. So, fuels and flames, let us see. Alright, so we know that first of all, that is, we are using LPG. LPG stands for liquid petroleum gas. And what gas is that? Mainly contains butane. Alright. Then you have CNG. CNG stands for compressed natural gas, and this contains mainly methane. So why we are using this as fuels? Because they burn, and when they burn they give a lot of heat is produced. Hydrocarbons, they burn hydrocarbons, they react with oxygen to produce H2O and CO2, and lot of heat is generated. This heat energy we can use for our different purposes, for cooking food or for automobiles or for whatever, for light also we can use. So that is the reason, that is we are using this as fuels and flames. So common, I told you, that is LPG, that is liquid petroleum gas, and CNG, this is compressed natural gas. Now we have fossil fuels. Fossil fuels is the dead remains of plants and animals buried under the sea. If it is buried under the sea, then plants are buried under the sea, then this becomes what? This becomes petroleum. And if it is under the earth, then this becomes coal. So these are known as fossil fuels. Petroleum and coal, they are known as fossil fuels. So this is dead remains under the sea, it becomes petroleum, and dead remains under the earth, it becomes coal. Alright, now next we have learned about fuels. Now see, flames we were talking about. So flames, when we talk about flames, we have got two types of flames. One is known as luminous flame, alright, and the other is known as non-luminous flame. Non-luminous flame. One is known as luminous flame and the other is known as non-luminous flame. Luminous flame is blue in color and non-luminous is yellow in color. Alright, then luminous flame, this will be given by what? This will be given by saturated hydrocarbons. And non-luminous or yellow flame, this will be given by unsaturated unsaturated hydrocarbons. Alright, so this will be this type of flame, this will be given by unsaturated hydrocarbons. Alright, now let us learn about some important compounds of organic chemistry. So first of all, let us learn about ethanol. Let us learn about ethanol. We have been talking about it. Eth means 2 carbon and all means OH group is there. So the structure becomes like this. Alright. So how we are preparation of this? This is prepared by fermentation. By fermentation of cane sugar. Fermentation of cane sugar. Cane sugar we all know we are using in our home. cane sugar को हम लोग साइंस में कहते हैं सुक्रोज. ठीक है, तो केन शुगर है, इसमें हम लोग डालते हैं थोड़ा सा यीस्ट बोल करके एक माइक्रो ऑर्गेनिज्म होता है. केन शुगर में हम लोग डालते हैं यीस्ट. यीस्ट डालेंगे तो यीस्ट जो है ये एनएरोबिक रेस्पिरेशन करता है और एनएरोबिक रेस्पिरेशन करने से ये पूरी तरह से इसको CO2 और H2O में नहीं बदल पाता है. इट विल चेंज इट इनटू इथेनॉल. ऑलराइट, this will change it into ethanol. So this process is known as fermentation. Now this alcohol, this is a very important compound. Now let us see some reactions. Some reactions of ethanol. Alright, some reactions of ethanol. सबसे पहले तो इसकी फिजिकल प्रॉपर्टीज को देख लें, है ना. फिजिकल प्रॉपर्टीज. इथेनॉल, दिस इज, it is liquid at room temperature. ठीक है, और इसका बॉइलिंग पॉइंट कितना है? बॉइलिंग पॉइंट इज 78 डिग्री सेंटीग्रेड. it will mixes with water at all proportions. It mixes with water at all proportions. Alright, so these are its physical properties. Then chemical properties में let us see the reaction with sodium metal. Alcohol ये बहुत ज़्यादा mildly acidic है, तो सोडियम जो है मेटल है, सोडियम मेटल किसी भी एसिड के साथ जब रिएक्ट करता है मेटल, तो इट प्रोड्यूसेस सॉल्ट एंड हाइड्रोजन. सो सिमिलरली जस्ट सी इफ इट इज C2H5OH and it reacts with the sodium metal, then it will produce the salt, that is C2H5ONA और H2 यहाँ पे निकल जाएगा. ठीक है, सो दिस इज अ वेरी इंपॉर्टेंट रिएक्शन. H2 को हम जानते हैं कैसे चेक करते हैं. H2 को टू चेक फॉर H2O, H2 it puts off a burning candle with a पॉप साउंड. तो अगर हम कहें कि एक हमने लिया सब्सटेंस लिया जिसको कि हम सोडियम के साथ ये कर रहे हैं, रिएक्ट कर रहे हैं, और एक गैस प्रोड्यूस हो रही है जो कि पॉप साउंड के साथ पुट ऑफ कर दे रही है, कैंडल को पुट ऑफ कर दे रही है, तो दैट मीन्स दैट दिस इज इथेनॉल. और ये रिएक्शन अगर आपको लिखना है तो ये इस कंपाउंड बना. इस कंपाउंड का नाम क्या हुआ? इस कंपाउंड को जब कभी भी कोई मेटल अटैच होगा तो मेटल हमेशा पहले लिखा जाता है. इसका नाम क्या हो जाएगा? सोडियम इथॉक्साइड, इसका नाम हुआ सोडियम इथॉक्साइड और हाइड्रोजन निकल गई। एक बार फिर से हम देख लें, दैट इज रिएक्शन विद सोडियम मेटल। इथेनॉल जो है बहुत माइल्डली एसिडिक है और ये सोडियम मेटल के साथ रिएक्ट करेगा तो क्या बनाएगा, सॉल्ट, और हाइड्रोजन विल बी रिलीज। सो सोडियम यहाँ पे हाइड्रोजन रिलीज हुई तो सॉल्ट जो बना, इस सॉल्ट को, क्योंकि यहाँ पे इथेनॉल था तो सॉल्ट विल बी नोन एज इथॉक्साइड। ऑलराइट, और हाइड्रोजन को टेस्ट करने के लिए हमने बर्निंग कैंडल साथ में रखी तो इट इज पुट ऑफ विद अ पॉप साउंड। ऑलराइट, नाउ this was about reaction with sodium metal. Now let us see dehydration reaction. Now let us see next reaction, that is dehydration reaction. डिहाइड्रेशन का मतलब क्या होता है? डिहाइड्रेशन का मतलब हो गया एक वाटर मॉलिक्यूल को निकाल देना। अब ये वाटर मॉलिक्यूल को निकाल देने के लिए हमें क्या करना होगा, C2H5OH, इसको अगर हम ट्रीट करेंगे क्या चीज से, कंसेंट्रेटेड H2SO4 से। तो कंसेंट्रेटेड H2SO4 का क्या काम होता है कि ये पानी को खींच लेता है। अब इसमें से अगर आप एक H2O को माइनस कर दीजिए, एक H2O को निकाल दीजिए तो इसमें क्या बच गया, ये बच गया C2H4, एंड C2H4 is, we know that this compound is ethene plus H2O. Alright, so C2H5OH कंसेंट्रेटेड H2SO4 के साथ जब ट्रीट करेंगे तो दिस विल फॉर्म ethene plus H2O. Now let us see the uses of ethanol. इथेनॉल के यूजेस देखिए, इथेनॉल के यूजेस, दिस इज, फर्स्ट ऑफ ऑल वी नो दैट दिस इज यूज्ड इन ऑल alcoholic beverages. अगर थोड़ी सी मिथेनॉल मिक्स्ड होगी इथेनॉल के साथ तो वो पॉइजनस हो जाएगी। ठीक है, ड्रिंकिंग पर्पस के लिए जो यूज होती है दैट इज इथेनॉल। इफ मिथेनॉल इज एडेड देन इट बिकम्स अ पॉइजनस ड्रिंक। दिस इज यूज्ड इन ऑल अल्कोहलिक beverages. Alright, then it is used as an antiseptic. कोई भी माइक्रो ऑर्गेनिजम्स को किल करने के लिए दिस इज यूज्ड एज एन एंटीसेप्टिक. ऑलराइट, देन इट इज यूज्ड इन द प्रिपरेशन of many medicines such as cough syrups, iodine tincture, etc. So whenever you are given that compound X, तो आपको कुछ ऐसे हिंट भी मिलेंगे कि ये आयोडीन टिंक्चर बनाने में काम आता है या कफ सिरप्स बनाने में काम आता है. So you should remember the uses of ethanol, that this is used as an antiseptic also. It is used for the preparation of cough syrups and iodine tincture, etc. Alright, now we have learned about ethanol. Now next compound, let us learn about ethanoic acid. Ethanoic acid. Alright, ethanoic acid, how do we write ethanoic acid? Acid is COOH, so this is CH3. IUPAC नेम हो गया इथेनोइक एसिड. इसका कॉमन नेम क्या है? कॉमन नेम है इसका ग्लेशियल एसिटिक एसिड. ग्लेशियल एसिटिक एसिड. Why do we call it as glacial? ग्लेशियल क्यों कहा जाता है? बिकॉज इन विंटर्स it crystallizes to form transparent solid just like glaciers, जिसकी लुक ग्लेशियर्स की तरह है, तो वी कॉल इट एज ग्लेशियल एसिटिक एसिड। इसका मेल्टिंग पॉइंट होता है 17 डिग्री सेंटीग्रेड। तो ये 17 डिग्री सेंटीग्रेड नॉर्मली तो ये लिक्विड फॉर्म में है। नॉर्मल टेम्परेचर पर अगर हम रूम टेम्परेचर 25 डिग्री सेंटीग्रेड पर देखें तो दिस इज लिक्विड, पर जैसे ही विंटर्स होगा बिलो 17 डिग्री सेंटीग्रेड टेम्परेचर होगा तो 17 डिग्री टेम्परेचर पर ये सॉलिड, ये जस्ट लाइक ग्लेशियर के आइस के फ्लेक्स होते हैं, इसी तरीके से इसका ट्रांसपेरेंट फ्लेक्स में ये सेट हो जाता है। सो वी कॉल इट एज ग्लेशियल एसिटिक एसिड, राइट? नाउ लेट अस सी इट्स केमिकल प्रॉपर्टीज। Physical properties we were talking about. First, physical properties. So this is liquid at room temperature and melting point is 17 degrees centigrade. So below 17 degrees centigrade, this is in the solid form, and this is a weak acid. This is a weak acid, and further 5 to 8% solution of this acid is called, used as a vinegar. Alright, it is used as a vinegar. Now let us see its chemical properties. केमिकल प्रॉपर्टीज में सबसे पहले रिएक्शन विद सोडियम मेटल, जैसे हमने किया था सोडियम मेटल। सो अगेन सिंस दिस इज नाउ एसिड, और ये एसिड है तो वीक एसिड है, बट हाँ अल्कोहल से थोड़ा स्ट्रॉन्ग एसिड है। सो रिएक्शन विद सोडियम मेटल, सो इथेनोइक एसिड and sodium metal, so this will give CH3 COONA plus H2 will be given out. Little bit if we balance over here, then this becomes 2 over here. The name will become sodium ethanoate. Sodium ethanoate. Alright, sodium ethanoate plus hydrogen is given out. Reaction with sodium metal. Fine. Now after this reaction with the sodium metal, since this is an acid should react with the base, so the reaction with base may we are choosing as NaOH. So we know that acid reacts with base to give salt and water, CH3COONA plus H2O. The name is, again we have seen, this is sodium ethanoate. Sodium ethanoate, and water is given out. Alright, so this is reaction with base. Alright, then third reaction, this is an important reaction which we call it as esterification reaction. Esterification reaction, esterification reaction. Alright, you may mark this as important reaction. Esterification reaction. This is what happens when acid reacts with an alcohol, then a molecule of water is given out and a sweet smelling product called ester is obtained. Alright, now let us see what it is. We are taking ethanoic acid and ethanoic acid, we are reacting it with ethanol. Alright, so I am writing ethanol like this, CH3 CO. Alright, so over here this is acid will give H and this ethanol will give OH. So one H2O will come out from here. One H2O will come out over here, and the product what we get over here is, you can see, this is CH3 and CO, and again we have got C2H5 we may write, or we may write it as CH2CH3, whatever we can write. Alright, this is CH2CH3. So this becomes what will be the name of this side. This group is known as methyl and this group is known as ethyl. Alright, so this is, since now you see ethyl and methyl, two groups are there. Now which one we will be writing first? Alphabetically, if we see, E comes first and M comes afterwards. So what we will be writing over here, we will be writing ethyl, methyl ester. Ethyl methyl ester. This is known as ethyl methyl ester. Alright, so this is when these are two, of course this is we will heat over here. So in the these two, ethanol and ethanoic acid and ethanol, when they are heated together, alright, then we get a product which is known as ethyl methyl ester, and one molecule of H2O is also given out. One molecule of H2O is given out. Alright, this process is known as esterification reaction. This is known as esterification reaction. Now see, now if this ethanol, how it is regenerated from this ester, how you can regenerate this ethanol from ester. Let's see. Say another reaction, what I will be writing is known as saponification reaction. This is also important. Saponification reaction. Saponification reaction. So in this saponification reaction, what happens? This ester, just now we had written ethyl methyl ester. So this is CH3COO C2H5. Ethyl methyl ester I have taken. Ethyl methyl ester, and in this ethyl methyl ester I am reacting it with NaOH. I am reacting it with NaOH. So what will happen? Again, what I will be getting from here is, that is in the with NaOH. Now this OH will attach with the C2H5OH it will become, that means alcohol is regenerated. And this sodium metal, this will react with the acid, that is CH3COONA. So that is we get sodium ethanoate and ethanol. Ethanol is regenerated, we get sodium ethanoate. Sodium ethanoate and ethanol. And since सोप बनाने में हम इसी प्रोसेस को यूज करते हैं तो इसी को ही हम कहते हैं सैपोनिफिकेशन रिएक्शन. सो दैट इज यू कैन अंडरस्टैंड कितनी बार ये क्वेश्चन आता है कि हम आपने अल्कोहल को हम वापस रीजनरेट कैसे कर सकते हैं और इस प्रोसेस को क्या कहा जाता है. तो इस प्रोसेस को हम कहते हैं सैपोनिफिकेशन रिएक्शन और इथेनॉल इज रीजनरेटेड फ्रॉम हियर. The reaction we were continuing acids ka reaction. So let us see reaction of acetic acid or ethanoic acid with hydrogen carbonates and carbonates. हम एसिड बेसिस के चैप्टर में पढ़ चुके हैं कि किसी भी कार्बोनेट को जब आप एसिड के साथ ट्रीट करोगे तो क्या प्रोड्यूस होगा, कार्बन डाइऑक्साइड. सो लेट अस सी, से सपोजिंग अगर हमारे पास है CH3COOH और हमने इसको ट्रीट किया NaHCO3 के साथ तो क्या प्रोड्यूस होगा, सॉल्ट, दैट इज CH3COONA plus H2O plus CO2. This is known as sodium ethanoate. And similarly, if it is CH3COOH plus Na2CO3, so this will give you CH3COONA plus H2O plus CO2 plus CO2. All right. So that is in any case CO2 is produced जब कभी भी आप एसिटिक एसिड में या तो सोडियम बाइकार्बोनेट डालें या सोडियम कार्बोनेट डालेंगे तो CO2 will be liberated. Now lastly in this, let us see what are the uses of ethanoic acid. Uses of ethanoic acid. So ethanoic acid, this is I told you 5 to 8% solution of ethanoic acid is used as vinegar to, and क्या चीज के लिए विनेगर होता है, to preserve pickles etc. Some vegetables are also preserved like this to preserve pickles etc. Then secondly, acetic acid, this is a, इसको कट कर दीजिए, used for making vinegar. So let us see uses of ethanoic acid. Uses of ethanoic acid. Ethanoic acid, since this is a mild acid, so this is first, it is used in the preparation of vinegar. Then secondly, used for preservation of pickles etc. And thirdly, it is used for the preparation of many important compounds such as esters. Alright. So with this we complete ethanoic acid. Last is chapter mein reh gaye soaps. Hello students. So we have done carbon and its compounds. Alright. And in this chapter there is a small topic which is soaps and detergents, which is again an important topic. So let's learn about that. So soaps and detergents, in our daily life we are using a lot of soaps and detergents. Alright. Soaps and detergents. What are they? They are also carbon compounds. So let us learn about what is soaps and detergents. So what is a soap? Soap is a sodium or potassium salt of long chain fatty acid. Alright. When we say long chain fatty acid, the general formula, if we write, then general formula will become RCOONA or RCOOK. That is sodium salt of fatty acid or sodium salt of potassium salt of fatty acid. Alright. Now this R will be equal to, R is equal to, either it is equal to C15 and H31, or it is generally equal to C17 H35. So the soap will be what? Generally, if we say general formula of a soap, generally soap is sodium stearate. Sodium stearate, that is C17 H35 COONA. Sodium salt of the stearic acid C17 H35 COOH. So when you add NaOH to it, you get RCOONA. Alright, so this is C17 H35 COONA. Now there is another term which we have used over here, that is detergents. Now why are detergents important and what are detergents? Let us see. Alright, so let us first write why are detergents important. Why are detergents important? Now we have hard and soft water. Now what is this term I am using? Water being hard. So we have hard and soft water. Hard water, what it is? Hard water, when water contains dissolved salts of calcium and magnesium. Now these salts, calcium salt, when we say, then it will definitely be either some anion will be there, calcium chloride, calcium carbonate, something will be there. So salts of calcium and magnesium. In which form? That is in the form of bicarbonates. Bicarbonate, how do we write bicarbonate? That is HCO3 minus. Alright, or it may be chloride, or it may be sulfate. SO4 2 minus. Now these salts, they are dissolved in water, and when they are dissolved in water, now if we apply soap in this water, then the soap will not form lather. It will not form, the foam will not form. We call it as lather. It will not form lather. So then we call this water as hard water. That is what we can write, that hard water reacts with soap to form insoluble scum. Alright, insoluble scum, and thus it does not form lather with soap. Soap does not form lather. So we call this as hard water. Now what is the use of detergents over here? We were seeing that we are seeing detergents. Alright. So that is why detergents. Now detergents, what they are? Detergents are ammonium salt. Ammonium salts of fatty acids. Alright. Or they are sodium or potassium salts of sulfonic acid. Sulfonic acid. Alright. How this is? General formula of the soap, we had written that this is RCOONA. Alright. Now for detergents, instead of this Na, I will remove this Na, and for this Na I will be writing ammonium. So this becomes ammonium salt of carboxylic fatty acids. Alright, the other form is, that is, instead of this carboxylic acid, I have a sulfonic acid, that is SO2Na. So this is detergent. Either it will be ammonium salt of carboxylic acid, or it will be sodium or potassium salt of sulfonic acid. Fine. Now these detergents, they will not form. The detergents do not form scum with hard water. With hard water. Hard water means with the calcium or magnesium salts which are dissolved in water. With hard water, and hence they form a good lather. They form a good lather in water and help in cleaning. Alright. So this is why we are using detergents. So you know what is soap and what is detergent, what is hard water. Hard water is when it is containing dissolved salts of calcium and magnesium. Calcium and magnesium salts are dissolved in the form of either bicarbonates, chlorides or sulfates. Fine. So water becomes hard. These sodium salts, they will react with these salts and they will form a insoluble scum. So the soap will not form lather. Now instead of this sodium salt, if we are using ammonium salt, then this becomes a detergent, and this will now not react with the calcium and magnesium salt. Alright, now let us see the action of soap, how the soap acts. Alright, so let us see action of soap. Alright, so that is, see what happens when we add soap to water. it breaks up. Since it is a sodium salt, so it is ionic. It breaks up into soap cation and soap anion. Alright, let us see how. If we are writing C17H35COONA as one molecule of soap, how we can write this? Say if this is C17, let me write over here. This becomes C1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and this becomes 17. So this is COO, and when you add it to water, this will become, Na will come out. This becomes the soap cation, and this long one, this becomes the soap anion. Alright, so in this soap anion, as you can see that the minus charge is at one end. So this end we will call it as polar head. We call it as polar head. Alright, and this is a hydrocarbon, C17H35. Hydrocarbon means it has got only hydrogen and carbon. So this is a long hydrocarbon tail. Hydrocarbon tail. Alright, now this polar head, this will dissolve in water. So we call it as, for water, we call it as hydrophilic, that is water loving. We call it as hydrophilic. And this hydrocarbon tail, this will be hydrophobic. This is hydrophobic end. Alright, so what happens? Alright, so we understand that one molecule of soap is, say, C17H35CONA, and when you add it in water, this will dissociate into Na plus and the long anion. Alright, now what happens is, that is, there is a term which we call it as micelle formation. Micelle formation. Alright, micelle formation. When we are adding soap to water, we are seeing the lather. What is this lather? What happens? That approximately 60 or more than 60 molecules of soap, they will come together. Now when they come together, what they will do? All their tails will come inside and their heads will protrude out. Heads will protrude out. Alright, and they will form a cluster. This cluster is called as micelle. Alright, this cluster is called as micelle. So micelle, how we can define micelle? That a cluster of 60 or more soap molecules in water where the polar heads protrude out in water phase and the hydrophobic tails peg in the oil are called micelle. Alright, now what I am talking about, peg, etc. Let us see. See what it is. What it is, that is, we have the hydrocarbon tail which is inside, and the hydrophilic polar head, which is protruding outside, all right. Now this hydrocarbon chain, which is hydrophobic, now this will peg inside the oil. Now our body, it is secreting a lot of oil, and this oil is getting attached with the clothes what we wear, and dust comes and dust is sticking on this oil, all right. Whatever हमारी body जो है, it is secreting a lot of oil, और ये dust सारी जा करके oil के साथ चिपक जा रही है. Fine. Now this dust जो oil के साथ attached है, which is attached with the oil, now when you are adding soap to it, what will happen? जो ये hydrocarbon chain है, this hydrocarbon chain, this is hydrophobic, means ये water से दूर भागेगी तो ये क्या करेगी, ये oil में अपने आप को पेक कर देगी, ठीक है, अंदर गाड़ दी, पेक कर दी. एंड दिस हाइड्रोफिलिक एंड जो कि वाटर लविंग है, दिस विल प्रोट्रूड आउट इन वाटर. और जिस वक्त हम इसको कुछ भी थोड़ा सा भी प्रेशर लगाएंगे, स्क्रब करेंगे हाथ से या ब्रश से या वॉशिंग मशीन में कुछ भी स्क्रब करेंगे, प्रेशर लगाएंगे, तो व्हाट विल हैपन, दिस डस्ट विल कम आउट इन द water. So this is how is the action of soap takes place. This process of, that is, a bridge is formed between the water phase and between the water phase and between the oil. So in nutshell, we can define that soaps are substances which decrease the surface tension of water and oil and help to emulsify them. So surface tension, we have used one word, surface tension. What it is? See, water over here, water surface, this is, if you will observe in a capillary, this is curved. So this surface is under tension because some molecules, they are pulling it from below. All right. And similarly, there is oil. Oil has also got its own surface tension, and water has also got its own surface tension. Now, these two surfaces, since they have got their own surface tension, so they are not mixing with each other. When you are adding soap to it, now soap, what it is forming? It is forming a bridge. Now these two surfaces, it will join these two surfaces, and these two liquids, now they will form an emulsion. When two immiscible liquids mix with each other, we call such a mixture as emulsion, and the substance which does this emulsification is known as emulsifier. So this process is, it emulsifies them. All right. So this is how is soap works. Thank you, students. So with this, I think this chapter is over. All the best to you.